Alright, welcome back to another video on my channel, math_exe. Today we're going to look at some more example problems of number patterns and sequences. So let's just jump into it. So question 1. The formula for the nth term of a sequence is t of n is equal to 4n plus 2 to the n. Pretty interesting. And part A says find the first 4 terms of the sequence, and that's just relatively simple. For the first term, substituting n equals 1, you get 4 times 1 plus 2 to the 1. 4 times 1 is 4, 2 to the 1 is 2, 4 plus 2 is 6. That's the first term. The second term, substituting n equals 2, this will be equal to 4 times 2 plus 2 to the 2. 4 times 2 is 8, 2 to the 2 is 4, this will be 12. For the third term, substituting n equals 3, you'll get 4 times 3 plus 2 to the 3. 4 times 3 is 12, 2 to the 3 is 8, so 12 plus 8 is 20. And for the fourth term, which means substituting n equals 4, get 4 times 4 plus 2 to the 4. 4 times 4 is 16, 2 to the 4 is also 16, this will be equal to 32. Now keep these terms in mind because this will be an essential tool for solving part B. Part B, given the first 4 terms of another sequence, I'll just write them on beside this. So T1 of the sequence mentioned in B is 3, and we have 9, 17, and 29. Now there is a relationship between the first 4 terms of the sequence in A, between this one, and the first 4 terms in sequence B, which is this one. So I'll let you guys find a pattern or a relationship between these two sequences, or at least the first 4 terms of these two sequences. I'll give you a couple seconds for this. Alright, if you haven't realized it, I said basically for each term in sequence B, you just subtract by 3 from each term in sequence A. So this is the pattern right here. And therefore, with this in mind, we can just write the formula for BI. The formula for the sequence in B will be just the formula of the sequence in A minus 3, which is just the difference between those sequences. So these type of questions often appear in some exam problems, and then you have to kind of like be intelligent at finding some patterns or some relationships between two sequences. And then with this in mind, you can just find the 6th term of the sequence mentioned in B, given we have this formula. So T6 will be 4 times 6 plus 2 to the 6 minus 3. This will be 24 plus 2 to the 6 is just 2 multiplied by 2 itself 6 times. And if you calculate this, you'll get this is 64. And then finally minus 3. So we're going to have 85 as the 6th term. So that's it for the first question. Let's jump into the second one. Alright, for the second question, given two sequences with their first 5 terms as shown. So you can just read this on your own. So for part A, The first part of part A is find the formula for the nth term in both sequences, which is pretty simple because notice these two sequences are both arithmetic sequences because we add or subtract a constant called the common difference to get the next term. So in this case, the common difference for sequence A, I'll just write this as dA is equal to 3. And then the common difference for sequence B is 4, because we add 4 to get the next term. So d of B is equal to 4. So with these in mind, we can just find the nth term of sequence A. I'll just call it A of n. A for sequence A. It's just the first term of sequence A, which is 2, plus n minus 1 times the common difference, which is 3. Simplifying this, we'll get 3n minus 1. And for the nth term in sequence B, I'll just call it B of n. It will be the first term of sequence B, which is negative 7, plus n minus 1 times the common difference, which is 4. Simplifying this, we'll get 4n minus 1, 11. So keep these in mind because these are tools for solving the next few parts. For part 2 of part A, we need to find the 8th term of sequence A. So that means A of 8. And then the 10th term of sequence B, which is B of 10. So A of 8 is just substituting n equals 8. It will be 3 times 8 minus 1, which is 23. For B of 10, substituting n equals 10, this will be 4 times 10 minus 11. This will be equal to 29. Alright? And for B, this is a pretty interesting and a tricky one in the same time. There is exactly one number that lies in both sequences with the same term order. So that means there is exactly one number that lies in both sequences. That means let's just call that number x. So x lies somewhere in this, somewhere right here, and dot dot dot. And this lies in the same term order. That means its positions in both sequences are the same. And if you understand this part completely, you can just notice that you can just set the formulas for an to be equal to bn, because the number itself is the same and the term order itself is also the same. Therefore, we're good to go for this. This will give us 3n minus 1 is equal to 4n minus 11. Add 11 on both sides to get rid of this negative 11. So you get 3n plus 10 equals 4n. Subtracting 3n on both sides, and you'll get that n after crossing out the positive 3n, and which is on the right hand side, is equal to 10. However, we're not done yet because we just found the term order of this. So whatever this number that lies on both sequences lies on both sequences and have the same term order, and the term order is 10. So all we need to do is to find the 10th term of either of these sequences, because we set them to be the same. So I'll just substitute it to sequence A. So A of 10 will be 3 times 10, substituting n equals 10, minus 1, it will be 29. This is the final answer. And if you want to do B of 10, this will be equal to 4 times 10 minus 11, which is also 29. Alright, for question 3, we need to find the next two terms of each sequence here. So you may pause the video if you want to try this on your own. Try to find some patterns of each sequences. Anyways, let's notice the pattern for sequence A. We add 1 right here, and then we add 2, and we add 1, and then we add 2 again, and then we add 1 again, and then therefore the next one we must add 2, meaning this term will be 11, and after that we need to add 1 again. This next term will be 12. So a tip for like finding a pattern of a sequence, you need to kind of like trial error for some patterns, maybe like trying to find the difference between each term and see if you can find a pattern from that. If you didn't, then probably do another way, or maybe just combine those to see what you'll get, because sometimes patterns are very unexpected, and therefore finding the next two terms given a very peculiar sequence that looks pretty random will be pretty hard. So yeah, that's the tip that I need to give you. Anyways, for part B, notice that we divide by -2 to get the next term right here, and then after that we subtract by 2. So we divide by -2 and then subtract by 2, and we divide by -2, and therefore the next we must subtract by 2. So -3/2 minus 2, if you compute that, you'll get -7/2, and then after that you need to divide by -2 again, meaning this will be equal to 7/4. Alright, for part C, notice the pattern right here. If we add this, we get +1 for this, and then we subtract by 2, and then +3, and then -4, and then +5. Therefore these signs are changing depending on the order of the differences. So after the positive you must get a negative, and then the initial numbers will just be increasing. So meaning this will be -6, this will be -2, this will be +7 or 5. Alright, for D is a pretty obvious one, but the only thing here is the signs kind of like change as you go on with the sequence. So notice there's a pattern with the fractions right here. So the numerator increases, and then the denominator increases, and the next term will be positive, because after negative you get a positive, and this will be positive 5/6. And then the next we know it will be a negative, it will be -6/7. So that's it for question 3. This last question will be the finishing touch of this video. So given a sequence, I'll just rewrite this right here. We have 2, 6, 12, and 20. And notice I have we've written these terms slightly different. So note that 2 is equal to 1 times 2. 6 is equal to 2 times 3. 12 is equal to 3 times 4, and 20 equals 4 times 5. So this is actually a clue to solve A, B, and C, but mainly A, because we need to find the formula first, and then we can just do the others from that formula. So notice this 2 is the first term, this 6 is the second term, this 12 is the third term, and this 20 is the fourth term. Notice there's some correspondence of numbers. Notice that this one corresponds with this one, this 2 corresponds with these 2, and then so on. And then the rest of these numbers, 2, 3, 4, and 5, is just a natural number above the number that you are multiplying with. So for the nth term, you can just quickly conclude that n, this is whatever. Notice that this n must correspond to the first number they were multiplying with, which is just n. And then the next number they were multiplying with must correspond to n plus 1, because it's a natural number above n. So I have n times n plus 1. And then with this you can just test things out. You can just substitute any n value you want to check if this formula holds true. So the answer for part A, Tn will be equal to n times n plus 1. Right, for B, it's pretty simple. You can just substitute n equals 100 to this formula. T of 100 is 100 times 100 plus 1 is just 101. This will be equal to 10,100. For part C, if the x term of the sequence is 1640, find x. With this, you can just set up an equation in terms of x. So we know the x term, so that means t of x is equal to 1640. And using our known formula right here, except we just change the variable into x. So x times x plus 1 is equal to 1640. And then with this you can just form a quadratic equation. So what you'll get is x squared plus x minus 1640 equals 0. And you may do this in various ways. You can try to factor this quadratic expression, or probably completing the square, or using the quadratic formula. However, what you ended up getting is two values. So the first one is x equals 40. That's the first one. And then next is x equals negative 41. So there are two possible values. However, we need to only take x equals 40 right here. Since x equals negative 41, notice this is less than 0. And if you substitute this into the question, if the negative 41 term, which doesn't make any sense, because negative terms, negative orders doesn't make any sense. I mean, come on. So we can just reject this. So our only answer is x equals 40. And that wraps things up for this video. Hopefully you guys enjoy this video. Please subscribe for more videos, and I'll see you guys in the next one. Goodbye.